All right, evening everyone. I'm going to make a quick video kind of by request about fixing up the Onan control board for the GMC Motorhome. This is the 6 kilowatt generator out of my 1976 GMC Palm Beach. Probably some similarities to the 4 kilowatt as well. I'm going to try to make this video as coherent as I can. No editing, no rehearsals, no tricks. I just want to kind of get the information out there. As I said, it was somewhat by request. Someone else is running into the same problem that I've had, which is K3 is bad. Your K3 doesn't look like this. This is from a Hyundai, and it doesn't work because I was too lazy to do the research. But I'm going to explain the problem I ran into and how to fix it. So first off, if you want to troubleshoot one of these generators, I recommend you get the custom schematic made by Ken Henderson. Just Google GMC Onan generator Ken Henderson. You'll find it on the GMC Motorhome forum. It is a lot better than the factory Onan schematic. It's the same. It's just rearranged so that you can actually read it, and yeah, it makes a little bit more sense. Symbology is a little odd on the Onan stuff. They've got contacts that look like capacitors. I'm not used to reading schematics from before when I was born, so anyway, these are the coils for the relays, and they're not drawn anywhere near the contacts for the relays. So it's just a little strange. Ken did do us a favor and show the connection between the contacts and the coils with dotted lines, which is a tremendous help. These things were even harder to read before that. So basically, if you've got, this is the problem statement, you got either no spark, no fuel, well, both probably, because they get power from the same place. And they get that power from the K3 relay. Connects power from, up in there, out to the coil. Well, not electronic ignition in everyone's case. But anyway, it goes to the fuel pump, and it goes to your ignition system, and it comes out of the K3 contact. So if you get power to the K3 contact, so you got power at pin 5 on your board, but you don't get power to pin 9, then you need to look at your K3. First off, is it getting energized? You can check that by checking power on R2 right here, and that is the red lead you see going in there to the left side of R2. That would be the left if this board was upright. If you get power there, well, we'll show you here. Turn that on. Set this to volts. What am I at? Nope, I'm screwing it up already. Hang on. Okay, the ground lead popped off, and I was already fumbling with that at the beginning of the video. Again, I'm not coherent. Let's see. Okay, so I've got 3.9. If you had not tampered with this the way I already have, you should see a higher voltage there. Maybe 10-ish volts. If your relay coils are okay, you might see 12 volts. If your relay coils are open, you should see battery voltage because it's open circuit. Also, I'm applying power at pin 10, simulating this thing cranking. So there's two different ways that this relay coil can get power. As you see at this node right here, there's two different input diodes for this path. So here in the run position, I've highlighted the path where power comes into the K3 relay coils, sorry. And here is in the start mode. When you're hitting the start button and you turn on the K1 relay, the K1 relay connects to pin 10 and energizes through diode CR5. Okay, so my problem is I didn't have the Ken Henderson schematic, and I was too lazy to look at it. I just thought, oh, this thing has a 12-volt starter, 12-volt battery. It's going to use automotive relays. Not exactly. So K3 Ken has spec'd as 1400 ohm. That's a little weird. And if you look up these numbers, these things are pretty hard to find. I didn't really find any current sources for this relay. So 1400 ohms is pretty high resistance for an automotive relay, especially one that's supposed to carry a decent amount of amps for your ignition system and your fuel pump. The trouble is, with that high of a resistance and a low voltage, the relay doesn't draw much power. With that much power, it can't make much magnetic field, and without much magnetic field, it can't have much clamping force between the contacts. So it's going to be prone to contact resistance over time and with oxidation and everything. And it seems to be a very common cause of failure on this board is K3. I think it's drawing a decent amount of amperage. It has a 100% duty cycle and not a lot of contact force. So that's the problem. I swapped in a normal automotive relay because I was too lazy to look at what I was actually doing, and it didn't work. Reason being, automotive relay is getting 3.9 volts. Well, obviously, if you look at this diagram, you can see K3 is fed through a series 150 ohm resistor. Ken put that label on there. Onan didn't, and I didn't bother looking at the parts diagram, and I thought, well, that's probably low resistance. It's not. If you put a automotive relay, this one's 80 ohms. If you put that in series with 150 ohms and subtract a diode voltage drop of 0.6 or 0.7 volts off your battery voltage, you end up with not enough volts to turn on the relay. So I don't want to try to go shopping for an impossible to find relay, and since this is Cheapskate Garage channel, we're gonna fix it with junk we had laying around. That's where the Hyundai relay came in. Junk car I had sitting in my yard, pulled a relay. Didn't work, but we're gonna make it work because I've got other stuff laying around. I've got a ST Micro P65NF06 MOSFET, N-channel MOSFET. So we're going to pop this in, and we're going to use this as kind of a relay to turn on the relay, because this relay sucks too much power. And then we're going to replace these relay coils with a 1400 ohm resistor. So that'll keep it from messing with any of these other circuits with the timers and stuff. So as far as the rest of the circuits are concerned, this K3 relay is still sitting there. And then we will tap in from that voltage to turn on the gate of this MOSFET. Like I say, it should be around 10-ish volts. I haven't done the calculation, I'm just guesstimating. I can do a voltage divider if I feel like it. And yeah, so I will start doing that stuff. Oh, and I can show you what this relay ohms out at if I turn off the power supply and just set this to ohms. And again, we're measuring the relay coil that I added in, and I'm tapped into pin 1 and R2 leg, the inside R2 leg with my multimeter. So 83 ohms. We need something that can handle that load. This is actually a 60 amp MOSFET. If you heat sink it and everything. We're not going to heat sink it, but it'll definitely handle the relay. No problem. Checking out the specs. One annoying thing you got to watch out for is the kind of mounting tab is actually hot on the TO220 package. That's always annoyed me. Like if you're using it as an open drain, that'll be the hot side. And then the gate will be pin 1. So we'll tap that into the high side of our 1400 ohm resistor. the source will go to ground, and then the drain will go to power. No, it'll go to the low side of the relay coil. Yeah. Anyway, I had drew this out somewhere and then I lost that paper. Not that it's complicated. One thing to note is the voltage from the gate to source has to be able to handle what you're going to apply. This is plus or minus 20 volts as absolute maximum, and 60 volt max for when you're turning things off. Oh, what else? Yeah, it's pretty highly rated. It is extremely overkill, and the reason why, I just had it laying around, and they're cheap. It doesn't matter. One nice thing, if you set VGS, your gate to source voltage, to 10 volts, you get a nice on resistance, an equivalent resistance from the drain to source when this is acting as a switch of 14 milliohms if the drain current is 60 amps. That's pretty low resistance. With low resistance, you have low power dissipation, and we shouldn't be burning this thing up. We just got to make sure that we get well above the threshold voltage of 4 volts. So that's where the 1400 ohm resistor comes in. It'll make sure that that voltage divider is nice and high. Actually, I'm even cheating a little bit, bumping it up just a tad, because the resistor I have laying around is brown, orange, red, which is no wait, that's 1300 ohm. I wonder if I should grab a 1500. I don't know, I'll think about it. All right, I should quit yapping and go ahead and do something. But some of the interesting graphs on here. What's the one I'm looking for? Nope, that's not it. Bear with me. Right, here we are. So if we set VGS to 10 volts and our amperage is on the low end, you can see our on resistance will be nice and low, like 13 or less milliohms. So very nice. Also, there's different curves here for different VGS, but you can see whether VGS is 10, 9, or 8, or 7, if our this kind of current over voltage is kind of related to our RDS on slope. You can see it's very steep, which is, well, more of a conductance curve than a resistance curve because it's inverse. But anyway, you can see that they'll have a very steep slope down here on the low end of the voltage that's developed across the low end resistance. So anyway, there's not going to be a ton of current, which means there's also not going to be a ton of voltage dropped across it. All good news. All right, that's probably way too much yapping. I'm just going to go ahead and start modding the circuit. I think I'll tip the relay over, glue it on its side, pop the resistor in place of the coils, and go from there. Okay, so as a quick sanity check, I guess step one of this whole process will be to remove the bad relay, whether you got blown coils or corroded coil or corroded contacts that you don't want to clean up or don't trust anymore. Just get rid of it, and we're going to put 13.8 volts because it's what we got, close enough. And again, I'm applying it to pin 10 to simulate the start circuit, and grounding pin 1. And now we've replaced the relay coils with the bottom two, try not to cast a shadow on you, with the bottom two contacts from the 5-pin relay. Replaced it with the 1.5K resistor. So out of 13.8, what do we get? 11.4. So our drop across our 150 ohm resistor and the diode and everything is not such a big deal now that we're not pulling it low with an 8 ohm relay. So don't do what I did. Now I just got to work the relay and the MOSFET in here to turn the relay on, and we will be done. One quick note about relay coils, though, is they're highly inductive, and so when there's current flowing through them, they make a magnetic field. When you try to shut the current off, the magnetic field collapses and creates a back EMF, or back electromotive force. It's basically a reverse polarity surge of voltage, so to speak, and that'll fry a lot of semiconductors because it peaks really high. So what you can do is put a reverse bias diode in parallel with the relay coils to protect, your semiconductor. But since this is a power FET, it already has what you would call the flyback diode built in, so we're not going to worry about it. I had originally grabbed a diode for doing that, but again, I just was grabbing stuff I had laying around. So we're going to skip that step and see how it does. All right, I'm going to go ahead and add the relay and MOSFET. All right, and the final step is to be done like this. Basically, so I had to power pin 11 because pin 11 powers pin 5 through F1, and pin 5 is where I decided to get power for the coil. The contact gets power from pin 5, so I figured the coil can too, because when a K3 needs to work, we should have power at pin 5. So K3 will always have power to the coil, and it only gets ground on the coil when this MOSFET gets power, and that's when either the start circuit or the run circuit is energized. So when the start circuit's energized, it gets it from pin 10. So let's power pin 10 and see what we get here. Nice click of the relay. And then our voltmeter is measuring pin 9, which is the output. You can hear the relay click. Pin 9 puts out power. I did put a little resistor between pin 9 and ground just to bleed off the capacitance that is there. Otherwise that floats at 0.7 and then 0.6 and floats for a long time. Normally you'll have the loads of the ignition coil and the fuel pump on there, and so voltages sitting there bleeding off aren't a problem. I was just wondering why I still had volts there when I disconnected the relay, and that was why, just capacitance. So I'll power down and show you how things are connected between the relay. Let go, let go. There we go. Okay, so basically the pin 1 of the MOSFET, the gate, goes right here, and that is on the high side of the 1.5K resistor that we put in, and the low side of the R2 from the original circuit. And then the source of the MOSFET, which is pin 3, also goes. So basically you just take the outer legs of the MOSFET and solder it in the same holes as the resistor, the 1.5K resistor, and put that in the holes where the K3 coil used to go. And then you can snip off pin 2 of the MOSFET, because as I said earlier, the mounting tab is also the drain, so that's the same as pin 2. So I soldered that to one of the coils. Now, some automotive relays, be warned, have a flyback diode in them to keep their coils from throwing off voltage. So if you have one of those and you measure the resistance of the coil in both directions, you might get a different reading. So to be on the safe side, hook the 86 should be the ground, and this relay is grounded through the MOSFET. 85 should be the power for the coil, and as I said, that is tapped into pin 5 power, the same as this contact, and that pin 5 comes from that trace. And then output on that goes to pin 9, and you can follow those traces around. If you hold this board up to a light source, it's real easy to see where everything goes. So anyway, that pretty much covers it. Again, this is a relay from like a 2013 Hyundai Sonata. Nothing special. It conveniently fits between the resistor and leaves the holes open. The only hole it covers is this one here that's not used, so don't worry about that one. I also repaired some traces on this board. You can see some more of the twisted wire there, glued down. I re-tinned and cleaned. I cleaned and re-tinned a lot of the traces that looked like they were starting to corrode, so they'll have a little bit more protection and a little bit less resistance. And I think this one's going to be good to go. If it works, I'll probably spray everything down with something to seal it. It used to have some sort of old conformal coating. I don't know, I might spray an acrylic lacquer or something on there just to kind of protect it. But I'll test it first. I might make a follow-up video showing the generator running, but obviously I don't have the generator on hand right now, so that'll have to come another day.